Huh? Good morning, everyone. Before going to this PPT or concept video belongs to the subject analog and digital electronics. This concept video analog and belongs to analog and digital electronics. Before going to the video, let me briefly discuss about myself. Sorry for that. Yeah, briefly introduce myself. Myself, Bhuvaneshwar. You can see my roll number on the screen. It's 21951a0527. You can see on the screen. And I belongs to the Computer Science and Engineering Department of Institute of Aeronautical Engineering from May section. This is my brief introduction. As you can see, yeah, this is and I yeah, as you know, this is from the Analog and Digital Electronics ADE subject. Yeah, without further delay, let us go into the topic. Let me show what is the topic. Let us This is the topic. uh, Discuss the tough form factor peak factor for full wave rectifier. In this whole PPT I am going to discuss what is tough form factor peak factor for full wave rectifier. I am going to discuss briefly. Yeah, with the, let us first see, as the topic is discussing about the tough form factor phi factor. Let us know what are the basic definition of each and every given the topic, like what is tough, what is form factor, what is peak factor. Before going to full wave rectifier, let us see what are the basic definitions. Characteristics of a rectifier circuit, like these factors are the characteristics of a rectifier circuit. Peak factor is one of the character. Peak, peak factor is defined as the ratio of the maximum value of the RMS value of an this is the ratio of maximum value to the RMS value of the alternating current. If you are given an alternating current, it is the ratio of the maximum value to the RMS value. The alternating quantities can be voltage or current. Like in the alternating circuit, the alternating values can be whether it can be voltage or current. Anything you can take. Next, the maximum value is the peak value of the crest value of the amplitude of the voltage or the current, and the root mean square value. Like the maximum value of the peak value of or the crest value of the amplitude of the voltage or current, and this root mean square value is the amount of heat produced by the alternative current will be some when the direct supply of current is passed through the some resistance in the same given time. This is the basic definition, like this is the basic point of the peak factor. I'll explain once again. The maximum value is the peak value of the crest value of the amplitude of the voltage or current, and the root mean square value is the amount, like root mean square amount of heat produced by alternating current will be same when the direct supply of current is passed through the same resistance in the same given time. Mathematically, it can be expressed as it is the ratio to peak value to RMS value. Like mostly it can be like you can describe peak value equal to you can see on my screen. I will show you RMS ratio of peak value to RMS value. Peak factor is equal to peak value divided by the RMS value. Yeah, sorry for the delay. Let us go inside the video. Yeah, now let us see another, as we discussed peak factor. Now let us see one other characteristic of rectifier circuit, which is form factor. Even form factor is another characteristic. Form factor in electronics, the form factor of an alternating waveform is the ratio of RMS means root mean square value to the ratio value average value, means mathematical mean of absolute values of the all points on the waveform. It identifies the ratio of direct current to of equal power relative to the given alternating current. This former can also be directed as the direct current that will be produced equivalent heat. Yeah, this is the basic definition of RMS. This will be produced equivalent heat. Form factor, it is the ratio of RMS value to the average value. Form factor is equal to RMS value by average value. Yeah, you can see on my screen. Form factor, it is the ratio of RMS value to the average value. Form factor is equal to RMS value divided by the form factor, which you can see on my screen. Now let us discuss another characteristics of a rectifier circuit, which is tough full form expands for uh, transformer utilization factor TUF. Tough transformer utilization factor TUF of a rectifier circuit is defined as the ratio of DC power available to the local resistor and the AC rating of the secondary coil of the transformer. Like as in the broad terms, you can explain it as the transformer utilization factor is rectifier circuit is defined as the ratio of the DC power available at the load resistor and the AC rating at the secondary coil of the transformer. Now let us give a formula for the tough factor. The DC power can be delivered to the load in అరే ఎక్కడికి రా ఎక్కడికి వచ్చేటప్పుడు నాకు ఫోన్ బయటికినా బావర్చి దగ్గరికి వచ్చాక ఫోన్ చేయనా బావర్చి దగ్గరికి వచ్చాక ఫోన్ చేయి వస్తావు కదా వచ్చేటప్పుడు ఫోన్ చేయ అంటున్నాను. The DC power to be delivered to the load in a rectifier circuit decides the rating of the transformer used in the circuit. Tough is equal to DC power delivered to the load divided by AC power rating of the transformer. Now, our topic is to discuss all these characteristics to the full wave rectifier. Let us see what does the full wave rectifier mean. A full wave rectifier converts an AC voltage into pulse. Like a full wave rectifier, every rectifier will convert in a full wave rectifier converts an AC voltage into pulsating DC voltage using both half cycles of the applied as AC voltage. In order to rectify both half cycles of an input, two diodes are used in the circuit. The diode feed a common load RL. In order to rectify both the half cycles of AC input, two diodes are used in the circuit. The diodes feed a common load RL with the help of center tap transformer. A center tap transformer is one which produces two sinusoidal waveforms of same magnitude and frequency but out of phase with respect to ground in the secondary winding of the transformer. Like the center tap transformer is one which produces two sinusoidal waveforms of same magnitude and frequency but out of phase with respect to the ground in the secondary winding of the transformer. This is a full wave. You can see the pictorial representation of full wave rectifier is in the circuit below. Like a center tape, as I mentioned, center tape, one of the load resistors in the center tape. You can see it. Like both the half cycles, positive and negative circles are connected into the single DC fluctuating cycle. Next, let us see what is another full wave rectifier. During positive half cycle of the input signal, anode of the diode D1 becomes positive and at the same time anode of the D2 becomes negative. Hence D1 conducts and D2 does not conduct. This load current flows through D1 and the voltage drop across RL will be equal to the input voltage. This is the basic working principle of full wave rectifier or center tap transformer, which is another name. During the negative half cycle of the input, the D1 becomes negative and the anode of the D2 becomes positive. Hence D1 does not conduct and D2 conducts. The load current flows through D2 and the voltage drop across RL will be equal to the input voltage. It is noted that the load circuit current flows in the both half cycle of the AC voltage and in the same direction through the load resistance. This is the representation again. Now let us see peak factor of a full wave rectifier. See, suppose peak factor is defined as the ratio of maximum value of the RMS value of an alternating quantity. Suppose, yeah, as discussed above, peak factor is defined as the ratio of maximum value to the RMS value of the alternating quantity. The alternating quantities can be voltage or current. The maximum value is the peak value of the crest value of the amplitude of the voltage or current, and the rho mean square velocity in the amount of heat produced by the alternating current will be same when the direct supply of the current is passed through the same resistance in the same given time. The peak factor of the full wave rectifier is peak factor is equal to peak value divided by RMS value, which means peak like as we know, peak factor for the full wave rectifier is Vm, and RMS value is Pm by root 2 by derivation, and we can cancel Vm by Vn, 1 by 2 will become root 2. Then we got peak factor of an full wave rectifier than root 2. This is the peak factor of full wave rectifier, which is root 2. Next, form factor of an full wave rectifier. In electronics, the form factor of an, like as discussed in the starting, form factor is an alternating current ratio of the RMS value to the average value of mathematically mean absolute values of the points of the waveform. It identifies the ratio of the direct current of an equal power related to the given alternating current. The former can also be used as an direct current that will produce equivalent heat. Where form factor, it is the ratio of RMS value to the average value. Form factor is equal to RMS divided by average value. As we before discussed, RMS value is equal to Vm by root 2. So average value will be 2 Vm by pi. Vm will get cancelled, and the at last form factor of the full wave rectifier is pi by 2 root 2. Yeah, as you can see, form factor will be pi by 2 root 2 is the RMS factor for form factor for the full wave rectifier. Next, let us see the tough factor. Characteristics of a rectifier tough factor. Yeah, in transformer utilization factor TUF, in full wave rectifier, the primary transformers carries current continuously, but the secondary current follows through each half separately in the every half cycle. Hence, tough is calculated for primary and secondary windings separately, and then the average of tough is defined as we can see. Secondary tough is equal to DC power delivered to the load divided by AC power rating of the secondary. Like as you know, as what before I discussed tough, what does tough mean? DC power delivered to the load by AC power rating of the secondary. AC power rating of the secondary is equal to VRMS of the input voltage into IRMS. Like as power rating, we can calculate V into as we know, power P is equal to V into I. As the same power rating, AC power rating will be PRMS of the input voltage into the IRMS, which equal to Vm by root 2 into Im by root 2, which gives Vm Im by 2, which is equal to Im square RL by 2. Yeah, this is the derivation for the RMS like AC or power rating. Next, now let us see DC power delivered to the load, ID square and IRL, which gives rise to as I mentioned before, IDC is equal to 2 Im by pi, 2 Im by pi into RL. It will be 4 Im square by pi square RL. Now secondary tough factor will be 4 Im square RL by pi square in divided by Im square RL by 2, which is equal to pi by 8 by pi square, which equal to 0.812. Now the primary of the transformer is the feeding two off-wave rectifiers separately. The two off-wave rectifiers work independent to each other, but they feed a common load. So tough primary winding is equal to 2 into tough of half-wave rectifier. As we know, tough of half-wave rectifier is equal to 0.287, which is equal to 0.574. 2 into 0.287 equals 0.54. So average tough of full wave rectifier is tough of primary plus tough of secondary divided by 2, which is equal to 0.574 plus 0.812 divided by 2, which gives rise to 1.386 divided by 2. It's almost equal to 0.693. Therefore, average tough of and full wave rectifier is equal to 0.693. Thus, in a full wave rectifier circuit, transformers gets utilized more than the half, like as compared to half wave rectifier, where only half of the AC current is connected, where tough factor for will be more. Hence, it proves that full wave rectifier use more efficient than the half wave rectifier. Now we saw all these factors of full wave rectifier. For the reference, you can compare the half wave rectifier, full wave rectifier, and bridge wave rectifier, each and every value in the given table. I gave this table for the reference. This is the table. You can go through it. Yeah, these are the other topic. Let me discuss what I discussed briefly again once again. First we saw the basic from starting of introduction. First we saw the what does peak factor mean. Next I discussed form factor, what does form factor and what is the formula. And next I discussed what is tough factor, and we go to implement these three characteristics for full factor. I gave brief idea what is the full wave rectifier. You got to know about full wave rectifier, and we implemented the three factors: peak factor, form factor, and tough factor for the full wave rectifier, and we got to derive desired formulas and values, and we discussed each and value. This is the whole PPT I am going to I thought to discuss to you. Okay, thank you.